So they also provide API for the .NET also. So here we have to cover first thing, what is the Python and OOPS concept. So everyone know the basic idea of Python. Yeah, any programming languages like Java, other, okay, Java.NET. So they know what is the OOPS concept. So here they basically mention the topics. What is the Python object class? What is constructor? Okay, what are polymorphism? What are data structure, inherent encapsulation, or constructor overloading? So this is related to OOPS concept. Basic. We also covered the basic things, which is very basic things like the fundamental concept, like what is the list set, what is the built-in function, expression, how can you loop. Okay, this is very what this is very basic things. Most of the members know, most of the candidates know these things. So who don't know, okay, we will cover it, okay, because this is very important. First, you know the Python, then you are able to write the code in Pyspark, and we have to move to the big data part, okay. So what are the topics we have to cover, okay? So we know, so if you don't go to the Pyspark, we know first we have to know about the Hadoop, okay. You know Hadoop advanced version is Spark, okay. Spark backend also they use the Hadoop things, okay. So first you know the Hadoop, okay. Why first starting the Hadoop, then we know that what is the drawbacks in Hadoop, why after the why they use the Spark, why not Hadoop. But most maximum company, okay, old company also use the Hadoop thing, but they are also migrating to the Spark, okay. They use the Hadoop all the things, Hadoop and Hive, okay. But this is old technology because we know many factors are there. We will explain it. Okay, why processing time, it will take too much time to process it. Okay, what are the features are not there in Hadoop? Okay, why they move to the Spark? Why Spark is going right now? You don't want to go to the Spark. Most of the company use the 80% company use the Spark. Spark as a language use Python, PySpark. Only few companies use the Scala and all. So here we can see what is introduction part, what is big data, okay, and what are the topics are covered here. Okay, what is Apache Spark? Okay, what a key picture? How can you install it? But installation we need a for you have Windows machine. If you have a Linux, so in a Windows machine you have to install one VM, Oracle VM something. Then you can manually install the Spark also and write the code. Okay, or else you use the Databricks, so you don't install anything. So you have to create simply, you have to create account, you have to create the account and directly write the code. So anyone work on Jupyter notebook in Python, so like that is Databricks also. So I'll show you how it looks like. Here architecture is there in Spark architecture. What are the main components are there in Spark architecture? Main components like a DAG, okay, and other many components are the core streaming for the real-time data, okay, like IoT devices, they're giving the data continuously, like that your IoT device, like your watch is there, they're giving, now you're walking or something like that. So you need real-time data for the, we are using the Spark streaming, okay. Spark SQL used for the they're giving this so you have to write a SQL query, as you know, you write the SQL query. So simply we can use the SQL query in a Spark also. Okay, you don't want to write a Pyspark code, so simply you have to use select star from table name, like that you can give give the data from the table. Okay, so this is the architecture and these topics, and from there, so here topics are there. So right now we don't know what is the RDD or what is the data frame and Spark SQL. So we'll explain. This is the topics are there. So all our things are important. Okay, this is the MLlib. MLlib for the machine learning. Okay, you know in Python they are in Python you have to use Python in data science. So sklearn is there. Sklearn, scikit-learn. For they have all the Python packages are there related to machine learning. So here in Pyspark they are giving the name is MLlib. Okay, so you have to use the MLlib. This is the random for decision tree, and this is the algorithm we have to use in machine learning. But in data science, this is related to data, is not a big data. Okay, so we'll go through that. Okay, how can you what is the machine learning introduction part, and how can you use the random forest or decision tree naive base. Okay, what are the theoretic part, when you to use random forest, when you to use naive base. Okay, and here this is overview part. This is Apache Karfa and Flume. Apache Karfa used for the streaming data. Okay, so you have to go to the concept only. The main concept is Kafka producer and consumer. Okay, so we'll explain it. What is, because most of the company use the Kafka also for the real-time data, for the real-time data. Okay, and GraphX is there, so you have to go through that concept only. GraphX mostly used by social networking sites like the Facebooks. Okay, they are used GraphX. So Spark provide this functionality GraphX. So we have to go through that. Okay, here you can see sorted path. So sorted path. So we'll explain it. Okay, right now we don't know, but they're using the page rank like that things. This algorithm in GraphX. And also we provide some interview questions which is asked in interview. We provide the questions also in Pyspark. Okay, you want other things, Hadoop in Hadoop also will provide it. This is the basic things. Okay, this is the courses models. Okay, they are not doing anything. They only copy from this to like they are using the services from AWS or Azure to copy the data. Okay, like they create the connection and copy the data. After that, landing to refine, in between landing to refine, they cleaning the data. This data is same, but in between they use the Spark by Spark. Okay, they clean the data. Like I already explained you. They have to special characters or other things. They're creating the framework like that. They handle many things, JSON data, CSV data. So in real time, you have to create one framework using PySpark. They are able to read, means don't know the CSV file, all the things. So you have to read. They have in the CSV file they have header, a comma separator, delimiter. So based on that, because the delimiter, based on that you have to read the data. And after that, from refine, so they have to use the transformation. You have to run any SQL query, means data is there. So in Spark, read the data through Spark. So they're creating the data frame. I'll explain what is data frame. Okay, there's representation of column, row and column, not Excel sheet. So, and then we can apply some input function for the transformation. And after a transformation, like a joining the many tables, okay, 2 or 3 or anything, and we have to store somewhere in other DB or other location. So this is the actual one. Up to curated, no? That is the big data role is there. Okay. So data means our raw data to all the cleaning, all the joining, all the transformation up to there. And after that, data science team use the data RBI team because data is there in a clean and this is not raw data, this is clean data. So anyone can use based on scenario. Okay. So this is the thing. So I will give you one thing. My screen visible. No? So this is the big data. This is not PySpark. What is the learning path for the big data role? Who wants to go to the big data? Okay. So their basic introduction is there and distributed system. Already to Hadoop, HDFS. What is HDFS? Yarn. Okay. What is the disk IO? Disk input output operation. So they use the map produce or high. Okay, they used by the in a Hadoop. MapReduce, I will tell you what is the MapReduce and Hive. Only go through that because we know the architecture why MapReduce in Hadoop but not used in Spark. Spark don't use MapReduce thing. MapReduce written in Java. Okay, Hive looks like for SQL query. Okay, they which one used in Java? No? Through Java, you have to write the code, read the data, and do something transformation. But through Hive, it looks like you have to run the SQL query. Simply, you have to run the SQL query, write the SQL query, easy task. Then after the memory Spark they are using for memory optimization. This is for this. Spark you work on in memory, means RAM. They pushing data in a RAM. This is and how to work on the disk. Okay, the processing data and the disk. The streaming they're using the Kafka and Spark. cloud, Databricks for the programming. Okay, we have to write the code, and NoSQL Airflow. You know, we are creating the Airflow Apache. This is Apache product, Airflow. So we have to create our flow like that. No workflow. You can call workflow. So scheduling part. You want to schedule something. You write some script. Cron job in Linux. So you want to run something in some specific time. So Apache create some. No, this is where to create one flow based on the scenario or project. So you have to schedule some script. You want to run this script in this time. Okay. So no human interaction. They automatically they're triggering our workflow, and like ingestion part. So they automatically trigger our workflow. They inject the data from our staging, from source to landing to the file, like that too. So they schedule it like that. So that time they use the Airflow. Most of the company use the Airflow. Okay. And some hands-on projects, and this is the learning path for the big data. So current openings in big data, many you can search in LinkedIn. So many openings are there for the big data role. So what is day-to-day big data developer data engineer? What is day-to-day activity here? In a real-time Scrum, they are for the agile. So daily 15 minutes after a Scrum meeting is there. Okay, meeting with stakeholders like the manager, customer. That too. You are meeting with the customer also. So here, data pipeline is there. So, through Apache Spark, we have to create a data pipeline. So first, so I will explain what is a data pipeline. Okay. In Azure, Synapse is there. In Azure, there also you have to create a data pipeline, and you have to constantly monitor that our existing pipeline already someone created pipeline, and you have to monitor it. So because you have to run the pipeline, sometimes failed. Some issue with the data sometimes failed. So you have to monitor it why it's failed. We go through that, and to support the testing activity, and any bugs are there. Maybe in a code, no, someone, let's example, I develop a code, and in the production some issues there. So you have to fix that. To go through that and check why you're facing this issue. So you have to fix that bug and support the deployment part and code migration data. So term is there big and data. Big means huge data, no term like that. So you know right now our digital right now we are in a digital world. Okay, in digital world, you are use the Facebook, Instagram, LinkedIn, any social media sites, YouTube. They are generating huge amount of data. Okay, every second they are producing huge amount of data. How can you Google handle that? Because Google search engine is there. You search something and quickly they respond. Within millisecond they have to you have to search something. They're giving that. So how much, how fast, how can handle this amount of things. YouTube also lots of contents are there. You know we can't imagine. Okay, Twitter also. So here we can see what is big data. Big data means huge volume of data. Okay, velocity is the variety of information. Means variety of information means many variety. Audio, video, text, image, which one is seen as my screen, PDF, all our things are data. Okay, assess that demands cost-effective, innovative forms of information processing for enhanced insight and decision making. Okay, why they use the enhanced insight and decision making? Okay, you have data, you have raw data is there, something is there, and you are not getting any value from that data. So no use for the company. So they simply have to delete the data. Why they storing the data? Okay, like Facebook, why storing the data, or Google some. Okay, so why? Because they have something. So that's why Facebook providing the free thing, but they capture our data and they use for other things, by the advertisement. They're selling our data to the advertising company. Someone, okay, people watching these things means they want these things. So they have developer. Facebook have a developer something. So they capture data and they get the inside they go to the our data like that. I'm surfing the Facebook. Okay, so let's some advertisements or something is there. So I click on there watching go to. So they want okay, this yeah recommendations like the Amazon. Okay, Amazon is there, Flipkart is there. So they are recommending something, no? Because we can't surfing and clicking on the items. So they know that okay, this guy searching for this thing. Okay, they mainly fascinate about this electronics item like the gadgets, phone, something like that. So they are recommending that. So they know they have value for our data. So that's why they are recommended it. So that guy, the developer, data science team go to the inside our data and the decisions they have to some decision also. So here terms are there that Twitter billions of tweets generated every day. Like billions of intelligent devices. Like I know something smart watches, a smart doors, or something. So the every time a smart AC. So every second they produce on data. They capture that. Alexa also there. Alexa they use by Alexa by Amazon also. So they are generating many data. They capture. That's why they are more intelligent. You have more data, so your prediction is your decision very more accurate. Okay. Till now, uh, here we know what is big data. So one day instant messaging in 2002 750 GB that time. Right now we can see total digital data to be created this year PB petabyte. This data, this much of data means 1 petabyte is there means 1.25 lakh GB. So you can imagine. So 204 Walmart have 500 TV data and 200 of London traffic camera. Only 200 left. 1 terabyte per day. Only London. 200 cameras there. In India how many cameras in a highway and expressway. Let's say so lots of data there. So you have to maintain all the data. We're handling all the so we need a big data. So we need platform. That's why Hadoop concept is come. Previously they storing data in our RDMS, but this is not cost effective, is very slow. Okay, we can't handle this much amount data. How can we handle the many GB array? So many CPUs, RAM, all the things to capture and process the data. So who can handle this? Anything, any issues is there in between any RAM or something? How can I handle? So next term is evolution. How can evaluate like that? So we can see the graph, which one explain. First started they use the RDMS. First start with the file system. Before RDMS, they're using file system like that, any file, like CSV, example, they're maintaining manually. So any human error is there, okay, or any duplicacy of the data is there. That's why they move to the RDMS. Okay, they have to maintain and processing files, no human error. Okay, after 2005, they use Hadoop. Okay, this is open source. Everyone can use, and then use the MapReduce. I will explain you. Okay, no, sorry. Before the 2004, Google released one white paper, one concept they're giving MapReduce. Okay, how can handle the MapReduce? So after they use this MapReduce, they're creating the Hadoop concept. Okay, 2005 and 2006. Again, Google released one more concept like a big table, big query. That the big table. Google GCP use the big query. The big table, these are big table. They handle data. In 2008, Yahoo, what they created 10,000 core Linux sort of core cluster empowering such means they are creating the 10,000. And in our system cores are there. No? So they creating one big uh, cluster in Hadoop in the next machine to process the data 10,000 in 2008. So I will explain what is the map reduce. Okay, so two terms are there. We can see map and reduce. Map in In Python also, map and reduce also know that. Map is key and value pair. Okay. So what is the map reduce? Map reduce is a processing technique. How can you process data? This is technique. Okay. Given by the Google. Okay. Their technique. And this is written in Java. Okay. So, so what is mean by map? Map means take a set of data. Okay, data is there. They take the set of data and converts to another set. Okay, of data, and where our individual data is there. Individual elements are our individual element broken down in a tuple, in a Python term. Broken tuple. Tuple which format key and value pair. Okay, using the map. What is reduce after the map? They use the reduce. So what reduce will do? Reduce talks which take the output from the map reduce, which will key value is there, pair in tuple. Output from the map has input and is combine all the data, combine the data tuples, okay, into a smaller set of tuples, and the sequence of things called a map reduce. Okay, so we know reduce task is always performed after the map job. So I will explain in more detail when I will explain the Hadoop. Then I will explain the map reduce, because you don't know the Hadoop, so you don't know the what is the map reduce. So only I go through the basic one. Okay, how it's work. So here we can see in 2010. Okay, Facebook announced the Hadoop cluster has 21 petabyte of storage. Okay, and 11 is grown to the 30, and again 1200 petabyte, and 12 the warehouse grows by roughly half a petabyte per day. Let's say Facebook receive only, they have only 100. Okay, and after that every day half petabyte per day they increase data. So that's why they announcing the Hadoop cluster. So I'll explain you what is the Hadoop and what is the cluster. Okay, you know term what is the cluster means? General term cluster.
Group of data.
No. Cluster means group of data is not called. Means cluster means group of similar things, normal things. No, we have to cluster things now. So cluster things we have to group same of persons or something like that. No, closely together. So they have to cluster. So same thing in real time in Hadoop, it is meaning is different. Okay, inside cluster, no, many machines are there. Okay, I will explain you. Okay, in a cluster, no, like that Hadoop cluster, Pyspark cluster. Okay, so they use many machines. Okay, because Hadoop work on distributed system. I already explained map reduce. Distributed means any data, like let's example you did some data is there. Okay, so you have to process the data. So they split the data into all the machines. Which one is there, no? Inside cluster? Like 10 machines means there are 10 nodes. Okay, 10 nodes. So they split the data of 10 record to split the data to the other, and they processing individually. Okay, so so it will fast. We need to do this distributed things. So that's why they're using the concept of cluster. So I'll explain you what is the Hadoop cluster, how it's work. Okay. So background for the distributing and processing thing, they use the map reduce. Okay, I'll explain these things. In 13, we know they use the Hadoop things. Okay, in 15, cloud distribution of big data gain popularity because of data you can see the graph. Data is going increasingly. Okay, in 18, IoT, machine learning, deep learning. On top of the big data, because I already explained big data, we have to clean the data, all the things, transform the data. After that, they use the MLDL, all the things on top of that. So this is the evolution of big data. So we can see data is very vast, increasing growth. Right now it's too much. Okay, Many companies like Netflix is there. Um, every time many companies daily open, okay, startups are there. So they have many data. If in today days, any company you have data, so you are rich. So that's why Facebook, Google is rich right now. Tesla is also capturing many data. So that's why they have, because they use the self-driving car. So when run this self-driving car, what they have cameras, okay. You have to go to they capture all the data. They capture the image, no, left side, front, back, all the things, and processing the data, okay. That's why they know that this is the light, yeah, where to stop, okay, this is the lane, something like that. So they have many data. Tesla also. Any doubts till now? So this is first class. I don't want to go very fast way. So dimension of big data is there. 5 V of the big data is there. Okay. So what is the volume, velocity, variety? Okay, variety, veracity, and value. So volume means easily the size of the data. Velocity means the speed at the data is generated. Means every second how much data is generated. Facebook, I'll explain you. Half of day, in a half day they are uh, in one day half per petabyte per day data is there generated. One variety is a different types of data. Different types means any data like that, audio, video, text, image, anything. Okay. So here you can see which one explain you value. Just having big data is of no useless. We can turn out into value. Means you have many data is there, but it's useless because it's useless when you don't have use. You have take the all the data, but it's not any company is there. Okay, let's example any company like that, advertisement company, other any company. Okay, like emotions company, like that some companies are capturing emotions, okay, of the guy. So they need image or different, but they capturing the text data. This is not useful for them. They need images of the face, so they have to capture the emotions of the persons, like they capture the eyebrow and retina, something like that. So here a common problem in training system is RDMS. Common problem. What is the common problem? Unimaginable size of data. Because day by day our data is incremented. So your RDMS, so we have to every day or some after 1 week, 2 week, you have to increase the CPUs, RAM, all the things to handle our data. So very difficult to manage it because how huge uh, your company is there. So how can you handle it? Okay, every day you have to add some other machines. So your technical systems don't scale up easily. Okay, and RDMS is costly. Building single system is complex. Means one, let's say one CPU right now is 16 GB. Okay, your data increases, so you have to add one more 64 GB RAM. Okay, 1 terabyte hard disk. Again after 15 20, again you have to increase like to 56 GB, and again RAM, and again like that 10 terabyte, something like that. So you're building single is very complex. Again, you have to increase it, but the performance very so you depend. It's not cost effective, okay, because very costly. You have to increase our RAM and in a single and like that hard disk also. And can't do the data analysis, machine learning, and predictive analysis don't have a common infrastructure. Means this is not they're not provide any common infrastructure to handle. You have to do something like that, data science things and other things. This is a common problem. So I use the scale up. No? Here I use the scale up. Just don't did not scale up. So the two terms they use, scale up and scale out. So what is the mean by scale up and scale out? So you know I already told you, they increase the configuration of any single system. Like you have one CPU, okay, you have to day by day data increase, so you have to increase increasing like that disk capacity, RAM. You have to data transfer speed also, so you have to that things you have to change it. So what is drawback? This is very complex. In a single machine, you have to do many things, and also costly, and this is very time consuming process because data can't handle. And you have to maintaining these servers, these CPUs, servers very time consuming. And scale out means you have to scale out means you have to break down our single system, very small system. This is called the commodity. They're called commodity. They're economical. Okay, they're let's example many machines. Okay, like that 16 GB RAM. So you have to commodity hardware. You have to create 2 GB RAM like that. One system is there, they have 2 GB RAM. Again, one system is there, they have 2 GB RAM like that, and they have given some hard disk like that 20 GB, 20 like that. 20 based on that we have to split it. So here you can see they mention that use multiple commodity machine and distributed the load of storage processing among them. So that's why this is called a distributed system. Okay, scale out is called a distributed system. So we know our data is come. So like that 1 GB data is come. So we have to distribute it to the our you have a 10 commodity machines are there. So split 10 machines, not a single machine. In scale out, you have to uh, you have to transfer the data in this on a single machine. It process the data in a single machine. It's very time consuming. Okay, but in scale out, you have to distribute the data in 10 different machines. Like that in a real time. Let's say one human is working on a one task. Okay, so they have many burden. This is time. So we have to split that task to the 10 guys in real time in a team manner. So they we can easily do it. Okay, they split the task. The same way they have to instead of having single system with 10 GB storage or 80 GB RAM, use 40 machine with they split like that. Use 40 machine 256 GB of storage and 2 GB of RAM. So they are doing the scale out. So I will show you this through graph also. The scale up by one single machine there, okay, data increases, so you can increase the RAM and hard disk. Again, they increase one single one scale out. One machine is there, okay, requirement is there, okay, data is increased. So you have to create same thing like a 2 GB RAM and 40 GB hard disk. So two machines again, they three. So we can handle it. Okay, any problem with any one machine, so we can easily replace it. But here we can see any problem with this machine, we can't easily replace it. So maybe chances of that data will in corrupt. Okay, we can't manage it. Anything happened, so but here you can say any machine is okay, any issue with this machine, so you can easily disconnect and replace it. But here you can't. In the scale up, you can't. So that's why our big data work on the scale up. Uh, Today I will go through the only basic thing. What is a big data? Okay, what is the term they use? Okay, so basic things. What is a big data? Any doubt on what is a big data? Why evaluation part and what is the common problems with digital system? And what is the scale up and scale out? Some of the drawbacks also there in scaling out. Okay, that's why problem is there scaling out. Okay, in the digital system, that's why concept is come Hadoop in Hadoop data bricks. They will handle all the things. How can handle the cluster and how can manage the cluster? You have many nodes, like 100, 200, real time, 300 nodes are there. Hello. So today first class, so that's why this 1 hour is completed. So only go through that. So after that, okay, next class we have to learn the Python. Okay, today I only go through that. What is the big data? Okay, so first you have to learn the Python. Then we can move to the big data. Then again I will go through these topics again. Okay.